Hi, this lesson is about trigonometric functions and real numbers. So, what is a real number? A real number is the set of all rational and irrational numbers. This is the notation for it. We use this kind of fancy looking R with the double line in front. So, what are rationals versus irrational numbers? Because the set of both is what our real numbers are. So, rational numbers are integers, fractions, and decimals that are either finite or repeating. So finite means they end. So examples would be this list that you see here below. So -5 and 3 are integers, as well as 0. So all of your positive and negative numbers are in this integer set. So this wouldn't be numbers like with fractions or decimals in them are not part of the integers, but then your fractions are also a rational number, as well as your decimals. And so this is an example of a decimal that's finite, 0.25. And then this 0.3 with the bar on top is how you represent a repeating decimal, and 0.3 with the bar means it's 0.3 forever and ever repeated. That goes on and on forever. And that's just another way to write the number 1/3. So if you actually check that, put that into a calculator, do 1 divided by 3, you'll see that it will fill up the whole screen of the calculator with all threes, 0.3333 forever. So those are your rational numbers. Then we have our irrational numbers, and irrational numbers are decimals that are not finite and do not repeat. So examples of that would be your radicals that are not perfect, like square root of 2, square root of 17. So if you put either one of these into a calculator, it will fill up your whole screen with a decimal that is not repeating and doesn't end. So although it looks like it ends because your calculator can only show you so many numbers on it, in reality, those decimals go on and on forever. And then two other examples would be these special kind of numbers that come up a lot in your math and science classes. So one is pi, and pi you might remember from maybe from high school that people say pi is 3.14, but that's only an approximate answer. So that's what these curly equal sign means it's about 3.14, but it actually goes on and on forever with different digits to the right of the 4. And E is a similar situation. It's about 2.7, but it actually goes on and on forever. So those are your irrational numbers. So what's a number that's not real? Those would be what we call imaginary numbers. And imaginary doesn't mean it's in your imagination. It's just part of a different number system. So for example, square root of -4 is equal to 2i. I representing the imaginary number. It's not a variable. And square root of -7, that's just I root 7. It's still an imaginary number, so not part of the real number system. So any answers that we get regarding trigonometry will be real numbers. So if you recall, when you're on the unit circle, the point on the circumference of that unit circle is represented by an x and a y with respect to a particular angle. And that angle would be wherever your initial side is and your terminal side, the angle created by the initial and the terminal side. And that terminal side could be in any of the 4 quadrants, and they could also be quadrantal angles. And so when you're looking at your trig functions with respect to the unit circle, your x and your y, that point that we just mentioned, X is your cosine and Y is your sine. And you can represent the other trig functions in terms of X and or Y. So for example, your tangent is sine over cosine, so that's the Y value over the X value. And the other three have a relationship with the first three. So secant is the reciprocal of cosine, so that's 1 over X. Cosecant is the reciprocal of sine, so cosecant is 1 over Y. And cotangent is the reciprocal of tangent, so that is X over Y. So recall the equation for your unit circle is x squared plus y squared equals 1. Well, since x is cosine, that's cosine squared of theta, and y is sine, so sine squared of theta. So this important equation here, cosine squared of theta plus sine squared of theta, is the first of three important identities called your Pythagorean identities, which are here on the right. And I really encourage you to memorize these because these help in the future to simplify expressions and solve equations regarding trigonometry. So your first one is the one I just mentioned. Cosine squared of theta plus sine squared of theta is 1. These two could also be flipped. You can say sine squared plus cosine squared equals 1. But the other two identities come from this first one. So if you divide this whole thing by cosine squared of theta on both sides, then you get your second identity. So if I divide the left side and the right side by cosine squared of theta, you will get 1 plus tangent squared of theta equals secant squared of theta. And if you do something similar, but divide the whole thing by sine squared of theta, then you get your third identity. So divide left and right by sine squared, you'll get cotangent squared of theta plus 1 equals cosecant squared of theta. So just something to keep in mind in terms of notation. And so this is this note here. I'm using cosine as my example. So cosine squared of theta is equivalent to the cosine of theta squared. So it's typically written the way it is here on the left, but it actually means what's on the right. And this is true for all 6 of them. So in terms of order of operations, you would actually be evaluating the cosine of theta first and then squaring it. So understanding that it means what's on the right is important in terms of evaluating expressions. So here in our first example, this really should be a review if you've done the other previous lessons. So we want to determine the quadrant where the angle theta exists given the following conditions. So it would help to refer to this picture here below. So where is sine of theta negative and cosine positive? Well, sine is negative and cosine is positive in quadrant 2. In quadrant 4, your cosine is positive in quadrant 4, but your sine is negative here. So remember, cosine are your x values, sine are your y values. So where is your x positive and your y negative? Is asking where is tangent positive and secant positive? Positive is secant could be positive. Part C here is asking where is your cosecant positive and your cotangent negative? Cosecant is positive and cotangent is negative in in quadrant 2 because cosecant and sine are positive in quadrant 2, but cotangent is negative. And mentioned in previous lessons, and that's students take calculus. And so A stands for quadrant 1, all are positive. In quadrant 2, so this would be quadrant 1 for the A. T stands for tangent, that's tangent and cotangent are positive in quadrant 3. And the C stands for cosine and secant are positive in quadrant 4. So again, you can remember it in terms of that saying. You could draw the picture that is above or remember it in terms of X's and Y's. Either way, any way you choose to remember it, you do need to know the signs, the SIGN signs of your trig functions. Circle looks like, and just to remind you of how to read that, your unit circle provides you with both the remember the X value is your cosine and the Y value of that point on the unit circle is your sine. So the point that corresponds to that angle on the circumference of the unit circle represents your cosine and your sine. All right. So the unit circle, and then I'll do that exercise again with your right triangle. So that's right here, sine of pi over 4. Pi over 4 is a 45-degree angle. So it's equal to sine of 8 pi. That's a quadrantal angle, and so although you don't see 8 pi on your unit circle, you should be able to figure out that 8 pi is the same as 2 pi. It just means that you've gone around 4 times, you end up in the same x-coordinate. So the cosine of 8 pi is just 1. Number 6 is in quadrant 2 on your unit. So tangent is sine over cosine. So that is your y value over your x value. There's your 5. Negative 1 over root 3, because the 2's will cancel. But if you rationalize it, multiply numerator and denominator by root 3, you get your answer of negative root 3 over 3. So now we move on to cosecant of 2 pi over 3. So where is 2 pi over 3? It's also in quadrant 2. Cosecant is the reciprocal of sine, so it's the reciprocal of root 3 over 2, which is 2 over root 3. And when you rationalize that, you get 2 root 3 over 3. So now we move on to your secant of 5 pi over 5 pi over 4. So secant is the reciprocal of cosine. So it's the reciprocal of negative root 2 over 2. So I'm missing a sign. Root 2, because we are in quadrant 3. Cosine and secant are negative in quadrant 3. And so we move on to the last one. which is cotangent of negative pi over 2. That again is a quadrantal angle, which means you've gone backwards. And so negative pi over 2 is right here. It's the same position as 3 pi over 2. Cotangent is cosine over sine, so that's 0 over negative 1, so it has a value of 0. So that's doing these same problems with your triangles. So let's look at the first one, sine of pi over 4. That's a 45-degree angle, and so that is right here. Remember, sine is opposite over hypotenuse, so that is root 2 over 2, and so same thing I got here. The entire unit circle, but you should at least know what all these points are on each of the quadrantal angles. So as I mentioned before, 8 pi is the same as 2 pi, and so cosine at 2 pi is 1. That's the point on the quadrantal here, value of 1. Then we're at 5 pi over 6. 5 pi over 6, so the reference angle for 5 pi over 6 is pi over 6, which is 30 degrees. So if I'm looking at this triangle here, tangent is opposite over adjacent. So that is 1 over root 3, but don't forget, 5 pi over 6 was in quadrant 2. Tangent is negative in quadrant 2, so we do have to put that. Cosecant, 2 pi over 3, that it has a reference angle of pi over 3, which is a 60-degree angle. And so cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so it's hypotenuse over opposite. So it's 2 over root 3, which is exactly what you see right here. And then rationalize it, you get 2 root 3 over 3. 2 pi over 3 is in quadrant 2. Sine is positive in quadrant 2, so we don't need to adjust for the sign. Then pi over 4, and we know that secant is a reciprocal of cosine. So the reciprocal, the cosine at a 45-degree angle is root 2 over 2, but the reciprocal is 2 over root 2. But secant, this is in quadrant. It's negative 2 over root 2. Rationalize it, you get negative root 2. And then finally, cotangent of negative pi over 2. Again, you do need to go back to look at your quadrantal angles here. And negative pi over 2 is in the same position as 3 pi over 2. So cotangent is cosine over sine. 0 divided by negative 1 is just 0. So 2 different approaches to identifying the values of your trig functions. You should be familiar with both and be comfortable with at least one of those methods. All right, so that's it for this lesson. Please give the homework a try. Good luck.